my results. And these aren't official results. These are not designed to convince anybody or be presented as evidence. I really did this more for myself, but I did document a little bit of it, and I figured you'd be interested in seeing some of these results, just for interest's sake. Again, I'm not trying to prove anything to anyone. The best way you could prove something is to do it yourself. But I figured you might be interested in my shadow stick sundial pattern and azimuth, taking the zenith angle at solar noon and also the azimuth of sunset. And again, this really was not planned. I just kind of did this sort of for fun a couple days ago on the Equinox. So the shadow stick sundial, this is set up on a windowsill, and I simply went out about every half hour, not out, this is actually the room where I work, and I just marked the gnomon. I was able to log into Nathan Oakley's Tracking the Sun on a Flat Earth Equinox hangout, which was a great project. It was a 24-hour hangout hosted by Nathan Oakley and a bunch of hardworking people, and it was really tremendous. So I was able to call in with some of my results. So this is what it looked like around solar noon, and this is what it looked like around 4:30. This is what it would look like when I was marking one shadow. So you kind of see the shadow. Now take a look at my gnomon, and again, this is just a bent paper clip. I just wanted something that could cast a shadow, but it really doesn't matter what you use for your gnomon as long as it's consistent. So that paper clip did not move, therefore my marks should be pretty accurate. And then this is what it looked like when the sun had gone past the window frame to the point where it was no longer casting any shadows. So I did take readings, and again, it wasn't exactly precise. I didn't take readings exactly every 30 minutes. You could see there's a gap there where I was a little bit distracted, but I did try to take readings regularly throughout the day. And I also wrote the time next to each reading, so if I want to go back later, and I could stick a ruler up next to this photo and measure exactly the distance. And I can also correlate that with time, like say minutes after 8:52 a.m. Then you can actually kind of get a pattern. Like I could graph that and see if there's like a pattern of time versus distance. That would be an interesting exploration. But you could put a line against these things, and I was really pleasantly surprised. I really did not expect these dots to be so close to a perfectly straight line. And again, I'm just recording these things with a pen, so you can see the dots are not razor sharp straight, but there's a little error. Of course, I'm a little scribbling with my pen, so it's not perfect, but these things were really a straight line. And another interesting thing is the solar noon. I didn't make a mark at solar noon. I made a mark a couple minutes later. But the solar noon is really essentially where the gnomon is closest to this line. Now here's where I took these images. This is a building with a south-facing window, and I've got the latitude longitude there, so you can look this up. And so let's zoom in on the building. And again, the red circle is approximately where I was recording these images. Let's turn the building around so that we're facing south. And what I did is the building is not exactly east-west. It's really close. And so I took very careful measurements, and it turns out the building is oriented 1.3 degrees from the east-west azimuth. Now, if you take a look at my pattern of shadows, measured from the windowsill, it's 0.8 degrees off of the windowsill. So what does this mean? So let's make a diagram so we can make sense of this. So let's start with an east-west azimuth. And this is an exaggerated diagram, the degrees aren't true, just to illustrate the point. So the building is 1.3 degrees off of an east-west azimuth, but my shadows were 0.8 degrees from the building. So what does that mean? It means I was a half a degree. I was a half a degree off the east-west azimuth. So let's take a look at an actual drawing that is really to scale, so you really get a sense of what my error was. So again, let's start off with an east-west azimuth, and then the top line is my pattern of shadows. So I was very pleased with this result, because again, I'm not using scientific equipment. I'm just using a paper clip and a ballpoint pen and a piece of cardboard. But I was very pleased with that. So next is solar noon, and again, I was able to log into the hangout hosted by Nathan Oakley, and here's just me, holding up the solar chronometer just for show and tell. And again, you start with a pencil, you stab it through an index card, you tape on a protractor to the pencil, and then you hang a weight, and it was just a string and a binder clip. Hang it from the VORTEX hole. And the idea is that you point the pencil towards the sun. So when you point the pencil towards the sun, you want to wait for the shadow to disappear from the index card. That's how you know you're perfectly aligned at the sun. And then you just allow the string to hang down. And I apologize that I did not end up taking a still photo, a quality still photo. This is just a screen grab from the video. So I did this live in the Hangout. And I could read the scale because I was standing next to it, and it was exactly 50 degrees. I'm sorry, it was 40 degrees on the scale 40 degrees on the protractor, which means it was a 50-degree angle of elevation. And again, it's a string. It was swinging a little bit, so I'd say plus or minus 1 degree. But as a comparison, my latitude at that location is exactly 40 degrees, 40.0 degrees north. So you can compare the angle of elevation with my latitude. So next is sunset. This is a thing from Google Maps, just for me to show you approximately where I was standing. Now, there was no photo. The Google Street View does not have a photo taken from that exact location, so this is off by about 6 feet. I'm standing about 6 feet to the left of the orientation of this, so it doesn't match exactly. But this, so let me just go back and forth. So you can kind of see some of the landmarks, but this is facing exactly west. This is a few moments. Maybe a couple minutes before actual sunset. I think this might be about halfway through sunset, and then this is literally seconds before the sun winked out, and it was exactly due west. So I just did this kind of for fun. I mean, I'm interested in collecting data, and I encourage other people to collect their own data. And I didn't do this to prove anything, but it was a pleasurable experience, and so I hopefully somebody is going to get something positive out of this. And I just want to encourage everybody, collect your own data, but also try to give somebody a smile today, or cause somebody to smile. So thank you. Equinox observations. These are my results, and these aren't official results. These are not designed to convince anybody or be presented as evidence. I really did this more for myself, but I did document a little bit of it, and I figured you'd be interested in seeing some of these results, just for interest's sake. Again, I'm not trying to prove anything to anyone. The best way you could prove something is to do it yourself. But I figured you might be interested in my shadow stick sundial pattern and azimuth, taking the zenith angle at solar noon, and also the azimuth of sunset. And again, this really was not planned. I just kind of did this sort of for fun a couple days ago on the Equinox. So the shadow stick sundial, this is set up on a windowsill, and I simply went out about every half hour, not out, this is actually the room where I work, and I just marked the gnomon. I was able to log into Nathan Oakley's Tracking the Sun on a Flat Earth Equinox